Okay, so today we are going to discuss about or moving towards module 4. So in module 4 we are going to discuss about the basics of mechanical engineering. Okay. So in module 1, 2, 3 it is mainly dealing with basics of civil engineering, and 4, 5, 6 it is mainly dealing with mechanical engineering. So in first series, we are going to study these two modules, that is module 1 and module 4, one civil engineering and one mechanical engineering modules. Okay, so in this module, that is in fourth module, we are going to study about thermodynamics. Have you heard about thermodynamics? I think you had studied in your lower classes thermodynamics. What do you mean by thermodynamics? I think this word or this name is familiar for you. Dynamics, thermo. What these words indicates, or what is the meaning of thermodynamics? Thermal, therm,
Heat.
heat. Okay, dynamics, dynamics, mechanical engineering. I mean, engineering mechanics. In this semester, you were studied dynamics, statics. What is statics and dynamics?
Move force statics. Move dynamics.
Yes, yes, dynamics is mainly dealing with bodies in motion. Okay, so we can say that dynamics it is something related to motion or work. Okay, so it is actually thermodynamics. It is derived from the Greek word that is therm. That is, it means heat, and dynamics. Dynamics means what? Work. So work and heat. It is combinedly studied in thermodynamics. Okay, what is the effect? Then, thermodynamics can be defined as the branch of science which deals with heat and work. Okay, it is the branch of science which deals with what? Heat and work. Okay, then it finds application in almost all energy producing and energy consuming devices. That is everywhere. That is in our body itself, we are producing some energy that is in the form of heat energy. Okay, so in everywhere we can see energy is consuming and producing or emitting. So wherever we can see this process, then we can include these under the category, or we can include this as the application of thermodynamics. Okay, so we can have a look of the application of the thermodynamics, that is thermal power plant. What is the process here? Thermal power plant, thermal energy is using, and in or by any of the method of works, and we can convert this thermal energy into electrical energy. So thermal power plant, that is here mainly here transferring, or here changing one of the energy into another form, usable form, by using some work, by doing some external work. So that is called thermal power plant. Then aeroplane, here also working, the engine is working. Okay, so here also some kind of thermal energy is using to doing some work. Okay, solar power plant, electricity is producing by using the heat energy or thermal energy. Okay, then also in air conditioning, engine, refrigerator, some kind of heat energy is producing or ejecting. So these are the applications of thermodynamics. Okay, have you understood? Okay, is it clear? Okay, then thermodynamic system. Have you heard about the system, surroundings, boundaries?
Yes.
Anyone? What do you mean by system?
Yes, miss.
Huh, what is system? That is any object or anything else, any object or system. That is, we are going to study the thermodynamic properties is called system. Okay, that is, this is the figure: system, surroundings, and boundary. Then system, It can be an object or any quantity of matter or a region in space selected for study to study the thermodynamic property. So if you're selecting a region or a matter to study the thermodynamic property is called system. Okay, then what do you mean by surroundings? Outside the system, the region outside the system is called surrounding. Okay, so what is boundary? In between this surroundings and the system, there is an imaginary line, real or imaginary line between this system and surroundings is called boundary. Okay, is it clear? Okay, system, surroundings,
No,
boundaries. Okay, I think this is familiar for you. You can write the name or you can draw this figure: system, surroundings, boundary. No need to write the entire definition. You can just write out a short note, that is thermodynamic system. Just write down system, surrounding, boundary. Already you know that is what is the system, surroundings, and boundaries. This very simple definition. Okay. The next one is about type of system. Okay. Which are the type of system? Open system, closed system, and isolated system. Okay, what do you mean by open system? What is open system? I think we were studied these things in our fifth standard itself. Okay, open, closed, and isolated system.
And
What is open system?
മറ്റേ എക്സ്ചേഞ്ച്
Uh,
നടക്കാത്ത
സറൗണ്ടിങ് ആയിട്ട്
what exchange? What exchange?
energy
In open system, open means what? Indicate open. Transferring is the. But what is the transfer? What are the things that open system will can transfer?
എനർജി
എനർജി
Energy and
heat,
ഹീറ്റ്
heat is a form of energy. Okay, right. Then another thing is also there.
mass,
Mass, yes. Mass and energy. Okay. So in open system, there will be a transferring of mass and energy. Okay. Then what about the closed system?
transferring,
What?
transferring നടക്കില്ല.
Transferring of which one? One of the thing can be transfer, then other one does not transfer. Okay, what is the thing? Mass or energy?
ഹീറ്റ്
എനർജി ട്രാൻസ്ഫർ
Heat. Heat can be
ട്രാൻസ്ഫർ
transferred, but mass cannot be transferred. And what about the isolated system?
ഒന്നും നടക്കില്ല.
nothing can be transferred.
Yes, nothing will be transferred in these systems. So you can have a look of this definition, that is open system which permits the transfer of both mass and energy across its boundary. Okay, there is a transferring of both heat and mass here in open system. Okay, can you say any of the example of open system? Can anyone say open system? If you're placing a cup of coffee on the table, what is the system there? Open system. Both mass and energy will transfer. After some time, if you touch that coffee, then what will happen? The temperature of that coffee or the tea will be what happens? Yes, decreases or lower than the previous one. Okay, and what about the mass energy? Sorry, mass
ചേഞ്ച് ഉണ്ടാവില്ല.
mass change ഉണ്ടാവില്ലേ? അതെന്തേ?
ഉണ്ടാവും.
Mass will be changed or the volume will be reduced a little bit in the form of water vapors. Okay, vapors will be produced. Okay, So there will be a bit change in volume, that is in the form of transferring of mass energy in the form of vapors. Okay, so that is called open system. If we closed that coffee or tea with a lid, with the help of a lid, then that is called a closed system. That vapor, the water vapor will stuck on the lid, and there will be no change in volume. Okay, but the heat will be transferred. Okay, temperature will reduce. Okay, so that type of system is called closed system. So that is the example. If we closed with the help of a lid, then that is called a closed system. Okay, then transfer of mass will not occur, but transfer of energy or heat energy will occur. Then isolated system means both mass and energy will not transfer. Okay, what is the example for isolated system? Flask, thermoflask. Okay, thermoflask. Okay, so just write down the type of system: open system, closed system, isolated system. Open system, no transfer of mass and energy. No transfer of mass and energy. And in closed system, transfer of energy only. Transfer of energy only. Write the short note. Okay, transfer of energy only. Then isolated system, both mass and energy. Both mass and energy. Okay. You can also write the example. Okay, is it clear? Okay. The next one is about thermodynamic analysis. That is, we can approach these system into two ways. We can analyze the system into two ways. That is macroscopic approach and microscopic approach. So what is meant by macroscopic approach and microscopic approach? The name itself said that it is micro and macro. So what is the main difference between macro and micro? Macro and micro. What is the level of approach?
matter അനുസരിച്ച് analyze ചെയ്തിരിക്കും.
Macro means?
വെച്ച് അനാലിസ് ചെയ്യുന്നില്ല.
That means macro means the analysis carried out by considering the gross behavior, that is entire behavior of the matter. We are going to consider the entire behavior of that matter. If you are considering a room, we will consider the entire room itself. Okay, so that is called a macroscopic approach. Okay, then it is an easy method to analyze the thermodynamic behavior of the material. If you are going to study the macroscopic approach of a room, that is if we are considering the property like temperature, we can easily measure the temperature by using a thermoscale. Okay, that is, we can easily measure the temperature or volume of a room very easily. So that approach is called macroscopic approach. Okay, then the structure of the matter is not an important matter for macroscopic approach. That is, if the in this area we are not considering the shape of the matter, whether the shape is triangle or it is cubic. There is no interconnection between the property, that is in temperature. Okay, so structure of the matter is not important in macroscopic approach, and it is a very few variables are needed to express the any of the equation to express the properties. Okay, in macroscopic approach. So these are the points. First one is macroscopic approach means what? The entire behavior of the matter or entire matter will be considered. Entire behavior of the matter will be considered, or gross behavior of the matter will be considered in this approach. Okay, it is an easy method. Okay, it is an easy method. Structure of the matter. Structure of the matter is not important. Okay, then few variables are needed. These are the main points of macroscopic. So then what about the microscopic approach? Micro means what? We will go to the Molecule level, yes, molecule level. Individual molecules will be considered here. So that is called microscopic approach. Okay, microscopic level. So it is actually difficult method. That is microscopic level itself. The name itself is feeling us some difficulties. Okay, so this is a difficult method to analyze the behavior of the molecule. Okay, then structure of matter is important here. So structure of the matter is important. A large number of variables are needed to express any of the things. Okay, so large number of variables are needed. Opposite are the, that is structure of the matter is here important. Here it is not important. Sorry, here in macroscopic level it is not important, and microscopic level it is important. So actually in this area, that is in our thermodynamics analysis, we are going to approach macroscopic level, not in microscopic level. Okay, so just write down this thermodynamic analysis, macroscopic approach and microscopic approach. Only write the things that I have mentioned, that is gross behavior of matter, and it is easy method. Structure of the matter is important. Okay. Macroscopic and microscopic approach. Okay, is it clear? Macro and
Yes.
microscopic approach. Okay. Okay, can we move to the next slide?
Yes.
Okay. Then thermodynamic property. Next one is about property. So what is property? So what are the thermodynamic property? Any property? Any example? Please tell me the example, or please tell me any of the property. Any of the thermodynamic property.
Temperature.
Temperature, volume, pressure. These all are the properties. So what do you mean by thermodynamic property? What is this property? Property means characteristics of the system. Character. So how we can define the character of the system? By character of the system is called property. Okay, characteristics of the system is called a property. So property is also called thermodynamic coordinates. Okay, coordinate system is mainly we are depending to mention any of the point, or to describe any point. So we can set that property is a type of coordinate system in thermodynamics. Okay, property is also called thermodynamic coordinate. Then example is pressure, temperature, volume, density. Okay, etc. So here there are two systems, system A and system B. So here system A and system B is entirely different. This difference is mainly because of the property. That is here property, pressure, volume, temperature is entirely different for the system A and system B. Okay, no need to draw this figure. Just write down these 3 points. Okay, characteristics of a system. Then also called characteristics of the system. First one, characteristic of the system. Also called coordinate of the system. Coordinate of thermodynamic. Then example P, T, V, rho എന്ന് എഴുതിയാൽ മതി. Okay, P, T, V. Pressure, temperature, volume, density. Try to write down the things in a short manner, okay? Then next one is there are two types of properties. That is, have you heard about intensive property and extensive property? We can categorize these properties into a group, that is intensive and extensive property. Classified this property, or we can group these properties into two categories, that is intensive and extensive property. Have you heard about these words? Intensive and extensive. Okay, what do you mean by intensive property? Intensive. The property which is depending upon what? Mass. Okay, depending upon mass, and it is called what? The property which does not depends upon mass and which depends upon depending on mass, that is called extensive property. And which property? The property which will not depends upon the mass is called intensive property. Okay, so intensive property means what? The property which does not depends on the mass of the system are called intensive property. Example: pressure, temperature, density. Okay, so pressure, temperature, density, property which does not depends on mass. Then extensive property, property which depends on the mass. Just write down these things that I am here under. Okay, depends on the mass of the system. Okay, extensive property and intensive property. Example is volume, energy. Okay, write down the things that I have underlined. Okay, does not depends on the mass and depends on the mass of the system. Okay, I will give you an example for the to get a brief idea about intensive and extensive property. Here I am considering two buckets and I am going to filling this bucket with some water. Okay, and I am going to fill this up to entire level. So what is the volume here? What is the volume? Which volume is larger or which volume is greater? First one or second one? So first one, the volume of first one is larger. So what about the mass? What about the mass?
Mass larger.
First one, the mass of the first one is greater than mass of the second one. Okay, clear? So this is V1 and this is V2. So here mass is, so here the property volume is depending upon the mass of the system. Okay, so if you are considering the density of water in these two buckets, so what is the density? What is the density? Density of water. Is there any difference between the density of water in these two beakers or in these buckets? Any change? Actually, density is a constant thing for any material. Okay, density of water is 1000 kilogram per meter cube. 1000 kilogram per meter cube. Okay, so density is a constant thing. There will be no change in density in these two buckets. Okay, density is a constant thing. 1000 kilogram per meter cube. 1000 kilogram per meter cube for water. Okay, so there is no change in density if there is a change in mass. Okay, so the density will not depends upon mass of the system. Okay, also in the case of temperature and pressure, there is no change in temperature and pressure while changing any mass of the system. Okay, is it clear?
Yes, miss.
Yes, miss.
Okay, intensive and extensive property. Okay, then thermodynamic state. Next one is thermodynamic state. Actually, we can define a system by the state, by any of the state. That is, this system is in the state. What are the state? What are the state? Actually, there are different types of state we know. So, any of the example state of the system. Liquid state, gaseous state, solid state. These are the examples. So how we are defining the state actually? How we are defining the state actually? Actually, these state is mainly depending upon the property of that system. if there is a change in property, then state of the system will change. For example, LPG gases. LPG gas. Actually, the LPG means liquid petroleum gas. Actually, the state is gas, but we giving some pressure into this gas, and we are converting that gas into something like liquid. Okay, so here we are actually changing its property, reducing its volume. So here reduction of volume means property will change. Okay, so here we are changing the property, and we can convert the state of the system from one state to another. Okay, so condition of physical existence of a system at any instant of the time is called a state. Okay, so we can define the state of the system like this, that is physical existence of the system at that instant. Okay, is called state. Okay, have you understood? Is it clear?
Miss,
Okay. Thermodynamic state. You can write this, the condition of physical existence of the system, or just write like this, physical existence of the system at any instant. At any instant. Physical existence of the system at any instant is called thermodynamic state. Okay. So these state can be specified in terms of property. State will depends upon the property. Okay, it can be specified in terms of property. The state can be specified in terms of property. State can be specified in terms of property. Okay. Have you understood what I am saying? Okay, can we move to the next section?
yes.
Okay. Then next one is thermodynamic process. Okay, when a thermodynamic system changes from one state to another, and that process is called, or we can say that that system undergone a process. Okay, then when a thermodynamic system changes from one state to another is called, another is said to have undergone a process. Okay, that is called process. Then here you can see two states are there, that is state 1 and state 2. Then state 1, the properties are P1, V1, T1, and it undergoes, that is, if we can change the state 1 from, we can change any of the system from state 1 to state 2 by applying some of the work, some load of work on that state or that system. So we can convert the state of the system from any of the state to any one of the state. Okay, here we are converting the system A, the same system, into a different form of state. Okay, so change of the system occurs, then the property will also be changes, that is P2, V2, T2. That is best example is LPG gas. Okay, okay, then here if the state of the system, if the first state is state 1 and last final state is state 2, and I think from these process there are a lot of status will be the that the system A undergone. So we can interpolate these states with the help of a graph. Then that path is, that line is called path. Okay, so we can just define that path is something, path is a line which we are creating by interpolating the intermediate state from state 1 to state 2. So that is called a path. Okay, interpolation of the points of every state with the help of a graph. Okay, so we can say that path is a collection of intermediate state between initial and final state. Okay, it is the collection of intermediate state between initial and final state. Okay, is it clear?
Yes,
You
miss.
can draw this figure. Okay. Thermodynamic process. Actually, we are not yet entered into the syllabus, okay? These all are the basic things that we need to study before entering into the syllabus. Okay. So you have to study these things or you have to understand these things before entering into the syllabus. Okay. So there is no need to write the entire things. You just write down the short note of these things, these basic things. You need to understand these things. Okay. Then next one is there are different types of processes. Okay, have you heard about isobaric process, isothermal process? These all are the process which we are familiar. Okay, that is isobaric, isochoric, isothermal, adiabatic, isentropic process. So what do you mean by isobaric process? Isobaric. Baric means pressure remains constant. The state in that system, the pressure is always constant. There is no change in pressure. It's called isobaric process. Okay, if a system we are considering a system and the system we are uh, giving it some work or we are doing some work on that system and converting the state of that system from one state to another, then there is no change in pressure in that system. There is no change in pressure in that system is called in that process. Then that kind of process is called isobaric process. Okay, is it clear?
Yes.
That is, we are considering a system. We are considering a system and we are doing some work to convert the state of the system from one form to another. Okay, so that change in state is called that is called a process. Okay, so in that process there is no change in pressure is called isobaric process. If there is no change in temperature is called isothermal process. If there is no change in volume is called isochoric process. If there is no transfer in heat, it is called adiabatic process. And the entropy remains constant is called isentropic process. Okay, just write down these things: isobaric, isothermal, isochoric, adiabatic, isentropic process. It is very important. Isobaric, isothermal. Also, you can write like this, that is P equal to C. It indicates that pressure is constant. Okay. Pressure, temperature, volume, heat, entropy. Thermal energy per unit temperature is called entropy. Thermal energy per unit temperature. At unit temperature, what is the thermal energy? So that is called entropy. Okay. Have you wrote this?
Entropy ഒന്നും കൂടി പറഞ്ഞുതരാ.
Entropy means thermal energy. Please write down thermal energy per unit temperature. Thermal energy at unit temperature. What is the thermal energy? Thermal energy. Energy of that system. Thermal energy of the system. Okay. So next one is cycle. What is cycle? Actually, what is cycle? You can define cycle. What is cycle?
It is a continuous process.
Continuous process. Okay. So I need a
Repeat
definition
on-
for the cycle. What?
Repeat ചെയ്തുകൊണ്ടിരിക്കുന്നു.
Once more, please. What is cycle? It is we can say that it is a continuous process, but its final and initial state is same. Okay, simply we can say that the final and initial point of the process is same. So that is called cycle. If my starting point and ending point is same, then that is called a cycle. Clear? Is it simple?
Yes.
Okay, a system is said to have executed a thermodynamic cycle when it is undergone a series of process. It undergoes a series of process, but the speciality or peculiarity is that initial and final state are identical. That is, if you are starting a process from one of the point, and we are doing some work or we are doing some any of the methods and undergone some of the process and reaching to the original position or the first position, initial position, the ending position or final position and the initial position is same. So this is a cyclic process. Okay, this is called a cyclic process. So we can just define that the initial and final position same is called cyclic process. Okay, just write down that initial and final state are identical. You need to write the things that I have underlined. Okay, that is initial and final state are identical. Just write down this cycle. Initial and final state are identical. You can draw a simple figure also. Okay, this is the first state. This is the first position and the final position. Final position and initial position are same. No need to write these figure. You can write any of the figure which is easier for you. Okay. Okay. The next one is thermodynamic equilibrium. Okay.
Okay.
The next one is thermodynamic equilibrium. Okay. What is meant by equilibrium? What is the equilibrium condition states that? What is equilibrium?
No change of
That is balanced state is called equilibrium. So, okay, simply we can say that balanced state is called equilibrium. Okay, if there are different types of equilibrium condition, that is mechanical equilibrium, then thermal equilibrium, chemical equilibrium. Okay, a system is said to be in thermodynamic equilibrium if it possesses mechanical, chemical, and thermal equilibrium. Okay, if we are saying that thermodynamic system is in equilibrium, a system is in thermodynamic equilibrium, it should be satisfy mechanical, chemical, and thermal equilibrium. Okay, both these three equilibrium conditions satisfied. Okay, then we can call that system is in thermodynamic equilibrium. So what is meant by mechanical equilibrium? Mechanical equilibrium means what? There is no unbalanced force within that system. There is all are balanced. Okay, all the forces are in balanced condition. Then that is called mechanical equilibrium. Then chemical equilibrium means what? There is no unbalanced chemical reaction in that system is called chemical equilibrium. All chemical composition does not change with the time. Then next is thermal equilibrium. That means what? There is no change in thermal energy. Okay, the system is said to be in thermal equilibrium. No heat transferring occurs in that system. So that is called thermal equilibrium. If the state, if a system satisfy these these three equilibrium conditions, then we can say that system is in thermodynamic equilibrium. We can write down these things in our next class. Okay, just note down this or just remind that these are the equilibrium condition: mechanical, chemical, thermal equilibrium. We can continue in next class. Okay, ആരും ലീവ് ചെയ്യല്ലേ?